Well, tubers, there's nothing I hate more than doing something twice, but that's where I'm at today. We're back over here working on this stupid little well. We overhauled the gearbox on this last time. I've done a couple of videos on this. And a lot of times people kind of harass me about the way I do things, and I sort of stuck my foot in my mouth saying this will work forever. Well, it didn't. We had a catastrophic gear failure in this gearbox once again. So before I get sort of into what happened here, let's just jump into this thing and tear it apart and get this thing tore apart. We'll kind of talk about it as we go. All right, so I got to split this gear case. This well is weight heavy, meaning that these arms, as it sits there statically, is trying to push down. It's not the right way to do it, but so I want to do it is hopefully I can just pull these bolts out. I have to take these loose on these caps, and I'm not going to disconnect the arms or anything, and let's have the weight sit on this bull gear through here. It'll all make a little bit more sense later. But okay, I rolled the belts off of it, and if you look in here you can probably see better that is broken in half. I'm going to pull all the bolts out of the top of this case, and we're going to split this case. Something like that. That may not look like it, but I bet it weighs 250 pounds. So we're up here at the machine shop. I'm going to press this gear apart, and then I want to kind of talk about what I think happened here. A little bit of a backstory for those of you that hadn't watched the previous video. So let me give a little backstory here about what's going on here, what's broke, kind of why this happened, you know, what the deal is. For those of you that hadn't seen the previous videos, and for those of you that have, I ran this thing out of oil. It had a sight glass, and the sight glass was dirty and stopped up, showed that it had oil in it. It didn't, and because it ran out of oil, I run this gear, the high-speed gear, and the high-speed pinion. I had this gear and the high-speed pinion made. That's the shaft that is the input to the gearbox. It's the fastest turning gear. And when I went to put this gear, press it into here, it basically fell down on there. Now this end here has not been welded up, and you can see it sits down on there. It's loose. And this is nominally 1 7/8 inches, and this bore, the way it was given to me, is exactly 1 7/8 inches, and this shaft was exactly 1 7/8 inches. I think that this was probably supposed to be about 3/1000 under 1 7/8 inches. That would give us a 3/1000 of an inch interference fit. I'm not blaming him. I don't know that for a fact, and it wouldn't surprise me if this was an aftermarket gear or something, and the two aftermarket gears were made differently, but you know, who knows, whatever. Anyway, even if this was his screw up, the only logical way to fix this was to take, and I thought at the time at least, to weld this up, to put some weld on here, and then turn this down so that it was about 3/1000 of an inch bigger, about 3/1000 over 1 7/8 inches. Okay, so what happened here is when I went to weld this thing up, I don't remember if I put any preheat on this or not. I probably didn't. But it was relatively cold, even if it was a few hundred degrees. And when I started welding on this material that was originally this gear, the original material, was heated very quickly because it had a welding arc struck to it. And then since the metal under it, since the shaft in this was cold, it cooled that metal very quickly as well. And this is probably a really high carbon steel, and those three things together caused this to probably get extremely hard. Now I've got a file here. This is the weld metal, and we'll be able to see if I put a file on it. We can mark it very easy. So if we get right under the surface of this weld, like right here, see the file just glides right over it. So the file will not mark it. That's pretty dang hard there. Anyway, this got extremely hard, and as this weld cooled, it caused a lot of stress on the surface as the metal cools and it draws up, and that probably started a crack to propagate around the outside ring. And of course, as this gear turns, it's flexed. It's trying to bend it like this, and that crack just propagated all the way through it till it finally broke. So at this point, my only options are either to buy this gear for $1,600, weld the shaft up like I did this one and turn it back down, perhaps bore this out and put a sleeve in this gear or something like that. This gear that he made me is a cast iron blank, so it can't weld it up with steel. Or to try to fix this one. And I feel like that any three of those are going to be somewhat of a makeshift repair, and since fixing this gear is not going to have to make me buy another gear, this is the choice that I have made. So plan of attack moving forward. I'm going to put this gear in my lathe and drill a hole up inside here, a 1/2 inch diameter hole, or whatever size drill bit I've got, it doesn't matter, inch or so deep. I'm going to take this piece of shaft and turn the end of it down so that it'll fit up in here. We'll get a nice alignment. And then to properly weld this high carbon steel, we're going to preheat this, weld it with hard wire MIG, and we're not going to have the strength that this thing originally would have had. However, I don't feel like we need it. The weld runs really slow and really smooth. We're going to weld this up the hard wire MIG. We're going to put it in my ceramic kiln, heat it up to the point that it, I forgot what temperature it was, 1200 degrees or something, that it will internally stress relieve. And then I'm going to attempt to anneal it inside that kiln. After that's done, and I got this big wad sticking off here, we can bring it back up here, and I can remachine this before I drop the other piece here. All right, the next thing we got to do is weld this up. I don't really know anything about metallurgy, and I'm not going to act like I do. I do believe that this is probably a high carbon steel. It's probably a 1045 or 1060. I'm not sure which, but it obviously is a relatively high carbon steel because it got super glass hard where what we got up next to it welded. I did a little bit of research on my phone, 10 minutes worth or less, and basically what I'm going to do is I have got a new toy, or a new toy as far as y'all never seen it before, a ceramics kiln, and we're going to make a heat treat oven out of it. So I'm going to put this in there, and I bought a thermocoupler for it with a readout. We're going to try to get this up to around 600 degrees, 600 or 700 degrees, 500 to 700 degrees I should say, before we weld it. We're going to preheat it, and then we're going to haul it, and I've got a welding lathe that I've been putting together. I'm going to have a video out about it later, but we're going to try to weld it. We're going to preheat it, weld it, put it back in there. We're going to heat it up to, I need to do a little bit more research, but probably around 1400 degrees to alleviate any internal stresses. And then we're going to follow the procedure or whatever the book says we're supposed to do to anneal this. I want this as soft as possible. The gear hardening is not, I'm not chasing a hard gear. We shouldn't have any problem whatsoever if these gear teeth are soft. In fact, a lot of these, the one I actually have to put back on here is cast iron. After it's annealed, we'll take it back up to the machine shop and we'll machine it, put a keyway and everything else in it. So this thing's been in there about 2 hours. I originally turned it to high and it got up to about 1,000. I turned it to medium and it dropped back to about 550, and it's now climbed back to about 775. I'm thinking that this thing's probably at least 600 degrees. I'm not going to be able to put a camera over here because this needs to happen relatively quickly. What I'm going to do is just basically put you over here. I'm going to show you my setup in the meanwhile. I've got to get an extension cord to plug this in, but I got my drill set up. I'll be able to clamp this quick. The welder is hooked up and ready to go, grounded to the table, and I'm thinking I'm just going to be able to prop right here and just weld away. There's probably not going to be a lot to show, but I'm going to stick you maybe right there on the wall. I might could do that. You might could see the whole thing actually. Let's see what we can get done here. One of the jaws fell out of my chuck. This way. The weld nugget ended up off-centered, and I don't know why that is the edge of where the bull gear runs, so we could machine about 1/4 inch off this. We could machine quite a bit off and actually not be a problem. I would like to not let this thing cool. My understanding was that if you let it cool before you stress relieve it, you get it up to like 1400 degrees, that it can crack, and I assume that's probably what happened before, is it cracked and I didn't know it. So I think I'm gonna go try to get this thing in there and then crank it up and get it hot. Well, when you weld cold, like I did this gear initially, on the last video, you can cause these little stress fractures on top because you've got these little pockets of carbon, and then it cools very quickly. It gets extremely hard, and then it's got internal stresses. If you put a drop of something that's hot and expanded and it sticks, as it shrinks, it's going to try to pull away and break. And I think that's what caused this gear to break. Anyway, what we're doing is two different things. This thing right now is up to about 1500 degrees, and that's the point that the steel becomes somewhat malleable. So if we created any internal stresses inside this weld, inside the gear, the softness of the metal now, of the steel, the actual meltiness of it, if you will, allows any of those internal stresses to relieve themselves, or there won't be anything in abide inside the steel. I may be in for a long night. I'm going to show you something that's mind-blowing to me. This thing is 1470 degrees and climbing, 1471. If we turn this to medium, look how quickly the temperature starts falling. 1472, 1471, 1470, 69, 68, 67. So this has got 4 heating elements in it. If you turn it to medium, that's only 1 heating element. If we turn it to high, it's back to 2. Now watch this. 63, 64. It already starts coming up on the gauge within like 15 seconds. So what is the next evening? I've let this cool. I've turned the temperature down on the kiln in a couple of increments and then finally turned it off. It's down to about 300 degrees, I think, 250, 300 degrees. I got this gear up here in this machine. I've been struggle busting trying to get this thing square and how to do it. And I got an indicator that just barely touching the gear tooth. And I can watch this thing. You may not pick it up very well on camera, but it's just going through there and just touching the top of them. and it's going between about 87, 86, 87, and maybe 92. That's about as good as I'm probably going to get. That's within about 5,000ths. These gears are not extremely picky on actual depth of mesh when you get to talking about actual precision numbers. I'm sure if this was within 20, that this gear would be fine. So the next thing I'm going to do is we're going to put a center in here. Okay, I have measured that gear over there, and I measure that gear as 1 inch and 7/8 plus 17/10,000ths. That's 1.8767. I want to use a nice round number, and we're going to add 33/10,000ths to that, and that'll put us at exactly 1 inch 880. And that's what I want our final dimensional size to be here. I don't know if y'all will be able to pick it up, but I can see a crack that runs almost all the way around this. There's some porosity in it, but it's mostly a crack. And I've machined through it, and the crack goes all the way down. I got a parting tool in this. I'm gonna see if I can dig this out, but I kind of feel like this is probably a lost cause now. I don't know if y'all can see that crack. It's kind of hard to spot, but there's a crack that goes all the way around that thing. In the junk iron trailer it goes. What do you think about my new table? I got me a new 1-inch thick plate steel table made. There's been a couple of weeks past since the last segment, and I want to kind of tell you what has transpired. I think that I had some dimensions wrong when we talked about this gear at the first. The old pinion was originally, this piece here, was originally 1 7/8 exactly. And the old gear, I dug it up out there that we tore up. This gear here that I had made, the old one measured about 2/1000ths of an inch under 1 7/8. Well, the gear he made me, the gear I bought that we replaced in the last video about this gearbox, is this high-speed gear. He cut and bore this to exactly 1 7/8, maybe like a half over, and so the old pinion would just simply fall in there. I made a phone call to him and asked him, trying to see if he thought he might have made a mistake, and he wasn't willing to admit that there could possibly be a problem. He just said he made everything to Idaho spec, and that was the end of the story. I called another place that makes gears for units, and asked them, kind of told them the situation, and asked them if they had one in stock, and they did. I said, hey, if you mail it to me and it doesn't fit, can I mail it back to you? And the guy says, well, that's stupid, let me just measure it for you. And the one that they had down there also measured exactly 1 7/8. So I feel completely confident that this gear was made wrong, and the guy that made it for me wouldn't fess up and make it right. Whatever, doesn't matter. I'm not in the warranty business, I just need my weld going. So I called the guy that made this gear for me, and I explained to him what the situation was, and he, didn't admit the fault. He said, I just made it to the spec, the book. And I said, well, will you make me a gear? Make me another low-speed pinion that'll fit this. And he says, well, I can do that. I'll make you whatever you want. And so ultimately that's what happened. I had to go pay him more money, $1,270 for this gear right here. And I measured it, and it is right. It's now 3/1000ths of an inch over 1 7/8. This is 1 7/8. That gives us 3/1000ths interference fit. Let's press this thing back together. It's already it's 3:30 on a Friday, and I would really like to make this thing run tonight. It's supposed to rain tomorrow. Let's see if we can make it happen. All right, he turned a step in this gear, so it should fall down in there a little ways. Let's go see if we can throw that thing together tonight. I got quite a northern blowing in. It's gotten really chilly. It has rained on this quite a bit, obviously. I don't think it hurt anything. It's probably some water in there. But due to the wind and the fact y'all seen me put this together 3 or 4 times, golly, about fell over. I'm just going to stick you over here. We'll just time lapse, and I'm going to slap this thing together as quickly as I can. Alright, I just turned the camera off. All I did was putting bolts in it. I got all the bolts put in. I got to put the oiling tray on it, and then I'm going to see if there's any water in the bottom of the gearbox. But we're going to drain the water out of the bottom of the gearbox and run it. I wanted to see it kind of oil everything up. And it looks like it certainly is. Alright, I got this thing done. I need to come clean this up. It looks pretty nasty. That gearbox used to leak. It doesn't leak anymore. We fixed it. We got it done. Got my chain back on her, holding it down. I know y'all are going to harass me about that. That beam is broke right there. That'll stay. Hopefully this thing will last for a long time. Got my dipstick, got oil in it. Well, here we are a week later. Of course, here comes the wind. This thing actually, when I cranked it up, didn't pump. I had to get a rig out here and do a pump change on it, and I went ahead and changed the pumping tee and the stuffing box. But I believe we're good to go. Everything looks good, nothing's leaking. Well, I got to finish out this video. I know the end of it was kind of condensed. I didn't put a lot of effort into videoing or editing or anything, the end of it, but it was supposed to be about the gear, not the gearbox. Y'all have already seen me put the gearbox together. There's been a lot of people on YouTube that I have watched, and I used to always sort of look for the little weird niche channels that didn't have a lot of followers, that maybe didn't have the best editing or whatever, but they were cool people. And I think that's, at least I aspired to be that. I don't want to spend a lot of money on cameras or have some big production, but some of the things I do I think are interesting, and I like to show them. And I could name quite a few of them. I was actually just watching one of my favorite channels, and what I said doesn't really apply to him. He does some really nice work. Is Dr. Carlson's Lab. He had a 1950s, I was sitting here watching it as I was doing some paperwork, 1950s power inverter. And if y'all ever want to watch weird stuff like that, he puts out some videos that are so long and boring, but they're so interesting, and I mean, I hate to make fun of him, and I'm not. He does some really, really cool stuff, in depth, extremely well done videos. Of course, I always watch Pay Dirt. There's a girl up in Michigan that I can't think of her name. There's several other people, that they're always come across the feeds on my YouTube. But one of them in particular was a fella named Hobo Shoestring, and he was a pretty interesting fella. They actually found him. He passed away probably last week. They found his body yesterday. He was probably had a pretty hard life. This is kind of what I take from it. But he seemed like a really nice guy, and he rode freight trains around the United States. If you've never heard of him, you ought to go check out his channel. His name's Hobo Shoestring. It seems like he's a pretty cool guy. Anyway, I got a few other things. I got some equipment I bought. I bought a tank truck. I'm working on finishing up a video for it. It needs everything about like the rig. I've actually started working on it a little bit too. I jacked with it a little bit yesterday. I'm going to try to get the tank truck video out in the next few days, depending on if I have time to edit it tonight, maybe tomorrow. But it's coming. I also want to talk about, I did 2 videos for the new leases, and I got 1,000 questions, which is what I want. That's my favorite part about YouTube, is the communication in the comments and the questions. I'm a little bit overwhelmed with the questions. They just got away from me. There's quite a few hundred of them, and I don't have time to sit down and answer every one. And I have decided I'm going to run one more video about the injection well, because there'll be a bunch of questions about that, and then I'd like to do like an answer video for all those questions that were asked, because they're really a bunch of really good ones, and they deserve answers. I just don't have time to spend quite a few hours, and you know, it's easy to read comments, and please leave them. That's my favorite part. But when I'm asked, you know, several dozen really complicated questions, it just takes a long time to type my answers, and it's a whole lot easier to do the video. So anyway, in a few weeks, I'm going to answer all your questions that you left on those previous videos. And if you're wondering why I've been sort of silent in those, I've just been busy and I'm kind of behind. I don't feel like I could ever get caught up now. Is that it? I think so. Appreciate you watching. Like, share, subscribe, and we'll catch you on whatever comes up next.